For factoring by grouping, you're going to use this method only for certain situations, certain cases. So when you see a problem where it asks you to factor, if you see 4 terms, that means that you're going to be factoring by grouping. So 4 terms mean there's 4 parts, regardless if it's positive or negative. When you have something like that, the first thing you got to check is, are the terms are in order. So to check if the terms are in order, we follow the next step, which is start off with highest exponent, counting down by 1. So you'll see what I mean by that looking at the examples that we're going to work on. So if it's 4 terms, and then you got to check if the terms are in order, starting with the highest exponents and then counting down. Now, there is another part for grouping, a special case, when there are multiple variables. So that means an example where it could have an x and a y, an a and a b, or an m and a p, or an m and an n. So when there's a problem with 2 variables or more, so what you do is group 2 terms with common factors as first 2 terms. So that what I mean is any 2 terms that has a common factor. For example, they both have x. For example, they both have a's. So you're going to put it as the first 2 terms, and then anything that does not have in common, you put it as last. You will see that with the last example, what I mean by this part here. So to review, when you factor by grouping, you would know you would do this if it has 4 terms. Next, you gotta check if the terms are in order, starting with the highest exponents, counting down by 1. And then you will see how I rearrange them in order. And then on the last example, you will see how I apply this part, trying to factor by grouping. In our first example, we have 2x to the third minus x squared minus 10x plus 5. Now, let's see. There's 1, 2, 3, 4 terms. So since there's 4 terms, and you see how they have different exponents and one is just a common number, so that means we're going to factor this by grouping. So once you see we have 4 terms, let's check if it is in order. We're going to start with the highest exponent, which is 3. So if we were to count down, that's 2, or square, which comes next, that's okay. So counting down by 1 will be just to the 1 power, or invisible, which is just x, that's okay. And then after x to the 1 power, or x, should be just a regular number, which is 5, that's okay. So, looking at this, these 4 terms are in order, starting with the highest exponent, counting down, 3, 2, 1. Now you can write it as an invisible 1 if it helps. So 3, 2, 1, and then number, or a constant number. So sometimes I might say number, sometimes I might say it as a constant. So if you hear me saying it as a constant, it just means just a regular number. So when we're factoring by grouping, what I usually do is break up into 2 halves. So what I mean by that is, since there's 4 terms, the left half will have 2 terms, the right half will have the other 2 terms. So what I'm going to do is break it into, this is the first half. Remember, factoring, I'm just dividing. And then here's the second half on the right side. Alright, now this ties into what was covered in 9.1, finding the greatest common factor. So once this is in order and I break it in half, so I look at the first 2 terms, the one on the left, I look for what's the common factor. They both have x, and they both have exponents. So when we're trying to find greatest common factor, we always use the lowest exponent. So from the right side, the first two terms, I'm going to use square. And then I do the same thing to the right side, the last two terms. I look at what's common between negative 10x to the 1 power and 5. The only thing that's common is the number, which is 5. Now, on the right side, the last two terms, what comes first is the negative 10x to the 1 power. So since the first term is negative, I'm going to, instead of just factoring out positive 5, I'm actually going to factor out negative 5. Again, I did it negative 5 because the first term of the second half, the first one, is a negative. So I'm going to factor out the negative. Alright, so let's take a look. So when we're factoring out, it doesn't disappear, it doesn't go away, it's just going to be outside the parenthesis. So x squared. So when I divide 2x to the third divided by x squared, it just become 2x. Negative x squared divided by x squared would be simply become negative 1. So you see how I have the x squared on the outside, parenthesis 2x minus 1. Now we'll do the same process with the right side, the last two terms. The negative 5 would be outside the parenthesis. So you see how I wrote minus 5 after the first set of parentheses? Open parenthesis. Negative 10x to the 1 power divided by negative 5 will become positive 2x. Positive 5 divided by negative 5 will become negative 1. So there, I grouped it with parentheses. Now, if you notice, or you take a closer look, you see how inside the parentheses, it's 2x minus 1. That means they're the same. If they are the same, that means you can actually group the one that's outside the parentheses together. So when you have two set of parentheses, if the terms are exactly the same, and keyword exactly the same, that means we can group the terms that are outside the parentheses together. So instead of x squared times 2x minus 1 and then minus 5 times 2x minus 1, the ones on the outside will be grouped together as x squared minus 5 parenthesis, and then the one that I underline, the ones that have exactly same terms, would be 2x minus 1. So in review, I find the greatest common factor of the left side and greatest common factor from the right side. On the left side I had x squared times 2x minus 1, and then after that I put negative 5 times 2x minus 1. Taking a closer look, I see that it's exactly the same term inside the parentheses, so all I did was group the outside terms as 1 and then rewrote 2x minus 1 as one factor. So again, I group the outside terms as one factor in parentheses, and then I rewrote the ones in parentheses from the beginning as one factor. So I wrote it one time. Group the outside factor as 1, rewrote it, the ones in parentheses as 1. And then this is how you're going to factor by grouping. And this will be your final answer. In our second example, we have 5x plus x to the third plus 50 plus 10x squared. So I take a look, I have 1, 2, 3, 4 terms. So this means we're going to factor by grouping, and we can't combine anything together, so for sure it's going to be factored by grouping. Next, we're going to make sure it's in order. So I typically start off with the highest exponent. So here's our highest exponent, and then what comes next is counted down which is 2. The only one that has the exponent of 2 is this. And then after 2 is 1. So that means the variable by itself, invisible exponent, this is the one with the invisible exponent right here. And then the constant number is the one that comes last. Alright, as you can see how I underline with lines, numerous lines. 1, that's starting off. 2, that comes second. 3, that's going to come third. And then 4, that's going to come last. So, when I'm putting them in order, highest exponents, which is 3, counting down by 1, which is 2. This one has 2 as the exponents. And then after that is 1. The one with the variable by itself, meaning invisible exponent, is this one. And then the last one is just a constant number, the one that has no variables. So as I rewrite this, as what comes first is x to the third. What comes second is plus 10x squared. And then plus 5x, because it's positive. And if it helps you, you can write that invisible 1. And then plus 50. Alright. Next, I want to divide my left side and my right side. So here's my left side, the first two terms, and then the last two terms are my right side. Alright, so on the left side, my common factor, my greatest common factor, is they both have x, and they both have exponents. So I use the smallest exponent, which is 2, on both terms of the left side. And then on my right side, I look for the common terms. The only thing that's common is the number, which is 5. And the greatest common factor will be a positive 5 because of the right side. The first term is positive, so that means we're going to factor out, or we're going to divide both terms by positive 5. Alright, so when we're taking out the greatest common factor, on the left side is x squared, so the x squared would be on the outside, and then parenthesis, x to the third divided by x squared, meaning that we're going to subtract the exponent from top to bottom. So 3 minus 2 will be just x to the 1 power, or invisible 1. And then positive 10x squared divided by x squared will simply become positive 10. X squared divided by x squared is just become 1. 1 times 10 is just 10. Alright, next, the right side, since I'm factoring out or dividing by positive 5, I'm going to write plus 5, as you can see how I wrote it out the parenthesis, and then open parenthesis. 5x to the 1 power divided by 5 will simply become x to the 1 power. You can write it there or leave it as invisible, plus 50 divided by 5, positive 50 divided by positive 5 will become positive 10. Now, as I take a closer look, I notice that the ones in parentheses are exactly the same. So if they are exactly the same, then the ones outside the parentheses, I can group it as one factor. So when I'm group it, it's going to be parentheses, x squared, and then plus 5, close parentheses. And then the ones previously in the parentheses, the one I underlined in brown, I'm going to write it one time. So x plus 10 in parentheses, and that's our final answer, factored by grouping. If you were to FOIL this, and if you FOIL it correctly or using the box method correctly, you should have your answer matching with this or this. In our third example, we have x to the third plus 4x plus x squared plus 4. Taking a look, there's nothing we can combine, so we actually have 4 terms, so we're going to factor by grouping. Now, we check if it's in order. So our first exponent, or again, first term is the one with the highest exponent. In this example, it's to the third power. So first. Next, counting down is 2. That's our second one. So the one that has x squared, that would be our second term. And then counting down one more time is x to the 1 power, which is this. If it helps you, here's our invisible 1. That will be our third term. And then the one without the variable, a constant number, that will be our last fourth term. So, as I put them in order, what comes first is x to the third. What comes second is plus x squared. What comes third is plus 4x to the 1 power. And then what comes last is the constant number plus 4. So, moving on, just like the last example, here's the left side with the first 2 terms. And then here's the right side with the last 2 terms. So, we're going to take out the greatest common factor from the left side. So what's in common is they both have x. And they both have exponents, so we're going to divide or factor out with the lowest exponent, which is square. Now we're going to do the greatest common factor on the right side. So the only thing that's in common is they both have 4s, so we're going to factor out, or also known as divide both terms by 4. And we're going to divide by, or factor out by, a positive 4 because the first term of the right side is positive. So, on the left side, right here, our greatest common factor is x squared, so that's going to be outside the parenthesis. X squared, open parenthesis. X to the third divided by x squared, so that means subtract the exponents, 3 minus 2, x to the 1 power. And then positive x squared divided by positive x squared will become positive 1. And then close parenthesis. Next, I will do the right side. So since I'm factoring out, or also known as dividing by positive 4, I'm going to write plus 4. And then open parenthesis. So positive 4x to the 1 power divided by 4 will become positive x to the 1 power. And then positive 4 divided by positive 4 will become positive 1. And then close parenthesis. So, taking a look at what's inside the parenthesis, you notice how it's exactly the same term. So if it's exactly the same term, then the ones outside the parenthesis can be grouped as one factor. So I'm going to write x squared plus 4 in parenthesis. And then the ones that are previously in the parenthesis, exactly the same term, exactly the same, I'm going to write it as x plus 1. Now, since it's to the power of 1, I just wrote just as x with an invisible 1 power. If you write it, if you put 1, that's okay, it's still correct. But if you don't, then it just means an invisible 1 as the exponent. And our final answer is x squared plus 4 times x plus 1. So that's our factors for x to the third plus 4x plus x squared plus 4. Alright, in our fourth example, I mentioned before at the beginning that there might be some cases where it has multiple variables. So in this example, we actually have a term with two variables, and then we have two terms with different variables. So this example has multiple variables. To specify, this example has two variables. So what we're going to do is group the one that has a common factor, a common variable, first. So that means we're going to write it out first. So what I'm going to do is I look at which one has the common variable. So we can see that these two terms has a common y variable. So what I'm going to do is I'm going to put it as the first two terms. So what I typically do is sometimes I would put the one with the highest number first. So 20x y and then plus 15y, and then after that the ones that I did not underline, the ones that don't have a common variable, I'll put that as last. So typically I will put the one that has x. So you see how I'll put my 20xy first. So this one has an x. So the ones that did not have common variable, I will put the one that has x first. So minus 12x and then minus 9. So here's my left side, here's my right side. So I'm going to factor out our greatest common factor from the left side. So what's in common is the numbers and the variable. So what's common between 20 and 15 is 5. And they both have y, so I'm also going to factor out the y. So what's common between these two is 5y. Now looking at the right side, so the only thing that's in common is the numbers, which is 3. Now, if you take a look at the first term of the right side, it's negative, so I'm going to factor out negative 3. Alright, so continue with factoring by grouping. So when I factor out 5y or divide by 5y on the left side, 5y will be on the outside of the parenthesis. 20xy divided by 5y will be simply 20 divided by 5 will be 4. Xy divided by y will be simply just x. So 20xy divided by 5y will be 4x. And then positive 15y divided by positive 5y will become plus 3. And then close parenthesis. Next, the common factor from the right side is negative 3. So since I'm going to factor out negative 3, it would be outside the parenthesis, open parenthesis. Negative 12x divided by negative 3 will become a positive 4x. Negative 9 divided by negative 3 will become plus 3. So taking a closer look, I notice how these two are the same, exactly the same. So that means I'm going to group the ones outside the parenthesis together. So it will become 5y minus 3 in parentheses. And then the ones that were previously in the parentheses, exactly the same term, I just write it as once, 4x plus 3. So that will be our final answer. Now, some of you might have questions. Why did we group the y's together? And I say that's only one way to solve for it. Some might say, why not group the x's together? Well, yeah, we can definitely do that. We can group the x's together as the first two terms. So if we group the x's together, now typically again, I would put the one with the highest number. So in this part, we're going to just group the x's together first. So 20x, y, and then minus 12x. Now the ones I didn't group together, which is negative 9 and 15y, so I'm going to put it as the last two terms. So what comes after negative 12x should be the one that has the variable as the first term here. So on my my left side, my first term has x and y. So the ones that I did not underline in purple, which are these two right here, the one that has a y will come first on the right side. So that would be the plus 15y and then minus 9. So see how on each side, here's my left side and here's my right side. So the first term has y in common. Just like in this example, here's my left side, here's my right side. The first term, they both have x in common. So that's how you determine the order. Alright, so here is my left side, and then here is my right side. So the greatest common factor on the left side is the number and the variable. In this case, what's common between 20 and 12 is 4. And they both have x, so that's what I'm also going to factor out. So 4x. And then on my right side, what's in common between 15y and negative 9 is positive 3. Now the reason I'm factoring out positive 3 is because the first term of the right side is positive. So I'm going to factor out positive 3. Now continuing on the left side, our greatest common factor is 4x, so it's going to be outside of parenthesis, 4x, open parenthesis, 20xy divided by 4x will simply become 5y. So negative 12x divided by positive 4x will become minus 3. Close parenthesis. And then on the right side, our greatest common factor is positive 3, so I'm just going to write plus 3, and then open parenthesis, 15y divided by 3 will be 5y, and then negative 9 divided by positive 3 will become negative 3. So taking a closer look, you see how the ones in parentheses, 5y minus 3, 5y minus 3, they're exactly the same. So they're exactly the same. Then the ones outside of parentheses, I'm going to group it as one factor. So 4x plus 3, parentheses. And then the one I underline in brown, I'm going to write as once, 5y minus 3. So that will be our final answer. Now as you take a look at the ones I boxed in red, here's the 4x plus 3, and here's the 5y minus 3. Even though they're in different order, since these two factors are multiplying, the order does not matter. They're still going to be the same answer. So it's the same thing as, if I were to use numbers, it's the same thing as 4 times 3, which is 12. It's also the same thing as 3 times 4. You see how 4 times 3 and 3 times 4, the order of the numbers are different, but when you multiply them, it gives us the same answer. It's the same thing as these factors in parentheses. 5y minus 3 times 4x plus 3 will give you the same answer, such as 4x plus 3 times 5y minus 3. So when you're working with multiple variables, it doesn't matter with the order of the answer as long as you factor it correctly.